One way we measure concentrations is molarity. There are several other types, percent by volume, percent by mass, molality, but molarity is probably the most common way we measure concentrations in chemistry. So molarity is defined as the moles of solute dissolved per liter of solution. So moles of solute divided by per liters of solution. So let's do 5 examples. First example. Okay, I have a 1 liter of an aqueous solution. So there's my 1 liter containing 0.25 moles of dissolved potassium chloride. What is the molarity? This is a fairly easy question. Molarity equals moles over solute divided by liters of solution. I have my moles, 0.25 moles divided by my 1 liter. So 0.25 divided by 1 gives me 0.25, and the units for molarity is capital M. So 0.25 molarity or molar is the units for molarity, and that's how we measure it. Second example. Okay, here I have 12 grams of sodium chloride. Uh-oh. Is added to a 0.5 liter beaker. What is the molarity? Okay, I'm not given moles in this problem, but I'm given grams. And we're going to have to first convert my grams to moles. So if I have 12 grams of NaCl, multiply, fraction bar, I'm going from grams to moles, so I have to divide by the molar mass. So 1 mole of NaCl, and I have to find the molar mass of NaCl, so Na plus Cl, 22.99 plus 35.35, it's going to be 58.44. So I plug this in, and I'm going to get roughly 0.205 moles. So the trick to this problem is if you're given grams, you have to convert to moles, divide by the molar mass. I can now plug into the formula. I have moles, 0.205 divided by my volume is 0.5 liters. So 0.205 divided by 0.5, you should get an answer to be 0.41. 0.41 capital M for molarity. Okay, third example. I have a 100 milliliter, uh-oh, solution containing 5.1 grams of glucose. There's glucose. What is the molarity? So again, I have to convert my grams to moles. That's one thing it's not given to me. I have to do some conversion. So 5.10 grams of glucose, C6H12O6. Again, I have to divide by its molar mass. So 1 mole over the molar mass, and I calculate the molar mass of glucose to be 180.18 grams. And once you plug it into the calculator, you get 0.028. Yeah, I'm just going to use a lot of the numbers. Moles. Okay, so I got my moles. I don't have liters. They give me milliliters. So how do I convert milliliters to liters? I move the decimal point. If you don't see it, it's always at the end. You move it over 3 spaces. So that's going to be 0.1 liters. So now I have everything. 0.028305 moles divided by 0.1 liter. And you're going to get an answer to be 0. And again, I round to the hundreds place in my class, 0.28 molar or molarity. So the trick to this is if you're given grams, convert to moles. And if you're not given liters, you got to convert milliliters to liters. You move the decimal point 3 spaces to the left. Okay, example number 4. How many moles is needed to make a 0.1 molar solution of HCl in a 2-liter solution. So here I'm given molarity. 0.1 molar means molarity. I'm given my volume, which is 2 liters. So I have this, 2.0. I have this. I'm looking for moles of solute. So I'm just going to plug it into the formula. 0.1 equals, I'm looking for moles of solute, x over 2.0. So I got to solve for my x. I'm going to cross multiply. 2 times 0.1. So 2.0.1, I get 0.02 equals my x. So in that case, how many moles would that be? It'd be 0.02 moles is my answer. Okay, last example. Okay, what volume is needed to make a 2 molar solution with 0.25 moles? So we have moles, so we're given this. 2 molar solution, so that's my molarity, that's this. And they want to know what the volume is in liters of solution. So I'm going to plug it into my formula, 2.0 equals, I have my moles, which is 0.25, and this time my x is on the bottom of the fraction, and we need to solve for x. Well, how do we solve for x? We're going to cross multiply, pretend that this is over 1. So I'm going to get 2.0x. So cross multiply 2.0x times 0.25 times 1 is just 0.25. Divide both sides by 2.0. And x is going to end up equaling 0.125. And we were looking for liters, so this is going to be 0.125 liters. All right, so we did 5 different examples of how to use molarity as a way to measure concentrations in chemistry.